Hi, everybody. This is Mr. Wells. Obviously, I'm not in class today. I'm on a field trip with my chemistry students, and I will not be back until the end of the day. So I made this recording for physical science. This is my second try. The first time through, for some reason, it didn't record my voice, so I'm hoping that it works this time. So what we got, and I touched on it yesterday with my students, the next 3 weeks, we're going to be digging into evidence of climate change and how humans are kind of affecting the globe right now. So what we're going to look at as far as the agenda this week, yesterday we talked all about misconceptions, so you should have a good idea about some of the common misconceptions that are talked about with climate change. Today, we're going to really dig in deep to climate change. I'm going to talk about what climate change is and then actually show you a bunch of data. You'll see a lot of charts today that help support the idea of climate change. On Wednesday, we're going to actually look at how much CO2, what your individual carbon footprint is and how much CO2 production you make throughout a year. And then we're going to have you do like a self-guided learning experience on Thursday and Friday. Next week, we're going to be talking about destruction of the rainforest, ocean acidification, and bleaching of the coral reefs, all contributing to or helping move climate change along. And then the week after that, we're going to talk all about plastic and the pros and cons of plastic. Then we have, after that, we'll be talking, have 2 weeks about space systems, and that'll be the end of our learning as far as this year goes. So we're within 5 weeks, we'll be almost done, and then we'll have 2 weeks for our final project that we'll have going on. So, Mr. Anderson, you can go ahead and pause it here. I just want kids to think about what is climate change in your own definition, in your own world. What do you believe climate change is? So take a moment, talk to your neighbors, talk to yourself, think about what your own definition of climate change is. So now that you've had some time to think about that, and you've maybe had some discussions with your neighbors about what is climate change, there's probably a whole bunch of different definitions that you came up with. Here we have a video of Bill Nye. Really smart guy, kind of the lead the world leader as far as climate change and activism. So he's constantly out trying to make people aware, educate people about the dangers of climate change and how we can prevent it. So, Mr. Anderson, I'll have you pause the video here, and then you can press play and have them watch this. It's a 5-minute video, and then come back to this recording. Excuse me. In this video that you just watched, Bill Nye talks a lot about how the oceans are affected by climate change, what people are doing to cause climate change, and what we can kind of do to prevent it. And he talks a lot about industry. So over the last 150 years or so, humans we've really changed the way we live. In mid-1850s, we're full go as far as the Industrial Revolution is talking, and that's where we started to make progress. For most of human history, we rode on horses, we fought with swords, we all produced our own food, no electricity until the late 1800s, and then all due to industrialization. In 100 years, we went from horse and carriage to Tesla motors now, where we have electric cars that are super great. And those are all things to be proud of. Like, the human race has done a lot of good things. But the problem is there's a lot that we haven't done that we could easily do. As far as our resources goes, right now, there is no reason that we shouldn't be clean energy. Fossil fuels are not necessary anymore. We have solar energy, we've got wind energy, we've got hydroelectric energy. Hydroelectric energy is energy produced by running water. I don't know if most of you guys know this, but Western Wisconsin has enough hydroelectric dams to run the entire state. The problem is they were all built in the 1960s and 50s and 60s, and they're out of repair because we haven't used them, because we haven't funded them, because we're funding fossil fuels so much. So these are all things that we need to do. It is not a debate anymore. These are changes that we have to make, or we're going to be suffering some serious consequences in your own lifetime. So rising CO2, what does that exactly mean? What we're seeing right now, 65% more CO2 in atmosphere since 1760. Now, what's significant about the year 1760? Well, in Great Britain, about 1760 is when we start to see the Industrial Revolution take rise. So since that point, 200, almost 260 years ago, we have 65% more CO2 in the atmosphere than we ever have before. Where's that CO2 coming from? From the fossil fuels that we burn. We pull it out of the ground as oil and coal. That's just carbon. Coal, oil, natural, that's just carbon stored in rock form. When we burn it, we produce CO2. We're releasing that carbon that has been stored in the earth. So burning of the fossil fuels actually causes 87%. 80% of our fossil energy comes from fossil fuels. And there's no reason for that. Not anymore. At one point, it was a good source of energy. It was reliable, and it still is reliable, but we have plenty of other resources that we could use. The technology is there. The industry is there. We could be using right now to solve our energy problem and help minimize the amount of CO2 that we release every year. The reason why CO2 is so significant is because, like we've talked about, you guys have heard about it probably almost your whole lives, greenhouse gases. CO2 is the largest produced greenhouse gas that humans are a cause of. There's methane, which also is a pretty intense greenhouse gas, and then water vapor also does contribute as well. CO2 is just the largest percentage as far as the greenhouse gases that we are producing. And what they do is they just block light. Light is just another form of energy, like heat. The more light we have in our system, in our atmosphere, the hotter we're going to be. So if we have more CO2, that's going to increase our temperature because less light, less energy is able to escape into space where it can't heat us up anymore. So, I mean, whenever we see smokestacks with clouds coming out of it, whenever we see exhaust coming out of a car, that's actually caused by a combustion reaction. A combustion reaction is just a fancy way of saying something caught fire, something exploded, and out of it are products, are CO2 and water vapor. So an exhaust pipe in smokestacks, that's what you're actually seeing coming out of them. Here's a chart that takes place over 400,000 years. And where we get this data from are ice cores in the Antarctic, in the Arctic glaciers. We actually can drill down and collect samples of ice. And in that ice, there's gas bubbles that kind of tell us how much CO2 was present in the air at that time. So we see a whole bunch of peaks and valleys in this chart. We have high points and we have low points. So it looks like almost every 100,000 years or so, we start to get to a high point in CO2 levels where glaciers started to melt, releasing CO2. As they start to reform, that ice starts to water turns to a solid, makes more glaciers, the CO2 actually goes down. And that continued for 400,000 years where we see this up and down, up and down, up and down pattern. Until about 1940, and then in 1940, 1950, everything kind of changed. So at that point, we now had put so much CO2 into our atmosphere that temperature didn't spike and stop at about 300 or 280. It kept on going to our current level, and it's continuing to rise. So right now, we're sitting about 380 parts per million CO2 in the atmosphere. And that's a lot of carbon dioxide. Compared to our high point about 100,000 years ago, we had 275. 200,000 years ago, about 275. Our highest point, other than right now, 300,000 years ago, we had 300 parts per million. So almost 100 parts per million more carbon dioxide in the air now than there has been in the last 400,000 years. And that's significant. That's definitely not nature following a pattern anymore. Something has changed. And this increasing in CO2 has resulted in changing climate. So as we add more CO2, we're adding more greenhouse gases, we get more greenhouse effect, temperature increases. And when we're talking about changing climate, we're actually talking about the average global temperature increase, okay? We're not looking at short term, we need to look at long term when we're talking about climate change. So not a week ago, not a month ago, not climate over a year. We want to look at many years. What is the temperature? What are the weather patterns over many years? And what we're seeing is that over many years, over a decade, over 2 decades, last 3 decades, we've seen significant increase in temperature. Now, when we're talking about increasing in temperature, we're not talking about 20 degrees a year, like average increase a year. We're talking about 1, 2, 3 degrees increase. And that doesn't seem like a lot, a couple degrees here and there, but on average over a year, over 2 years, that's a significant increase in temperature. What we have, I'm just doing a recording for physical science, Noah. So what we have going on is like we saw in January. In January, we started with 50 degrees. There wasn't any snow on the ground. But then fast forward a couple months later, or a couple weeks later, into February. This February was the snowiest February on record. And we've been keeping track of weather patterns for over 120 years. And this February was the snowiest. So we can't use that to base climate change. Weather varies. It happens. But what we need to think about is that average over a long period of time. So what we're seeing is like February. We're seeing more extreme weather changes over periods of time. We're seeing more intense storms. We're seeing heavier downpours, more tornadoes, heavier flooding. If we look at this map here in the bottom left, trends in flood magnitude. If I look at the Midwest, the green arrows represent an increase in flooding per year. The more floods that are occurring in the Midwest. If we look at the brown arrows, those are telling us we're actually experiencing more droughts. So the bigger the brown arrow facing downward, the less rain they're getting, the more times they experience a drought, which can be very significant to those types of areas. California has been suffering from this significantly over the last couple of years. This last summer, they had the biggest fire that they've ever recorded because it's just been so dry over there. We don't get any rain to put those fires out. We can look at sea temperature as far as climate change goes. So if you look in the top right here, I've got a map of the globe, and anything that is yellow to dark red is showing an increase in temperature. So if we look at this map, we can see that across the globe, we are increasing in average ocean temperature where we collect this data, except for one spot. Take a moment. Where's that one spot? What's significant about the one spot where it's actually the average ocean temperature is actually cooling? So yeah, it's Greenland. If we look at the map, we've got Greenland northeast of the United States, and it's blue. Blue is saying that we've experienced a 1 degree less average temperature. We've decreased by 1 degree. Does anyone have a reason why? So the reasoning why is Greenland is covered in a massive ice sheet. And as that ice sheet melts because of this increasing temperature, this climate change that we're experiencing, that water goes into the North Atlantic and actually cools it down. So that's why we're seeing this one spot on the entire globe where the ocean is actually colder than the average. So here's another graph showing annual temperature anomalies. So what's our temperature change throughout a year? What does it look like? So we see a lot of up and downs. This chart starts about 1885, 1880, somewhere around there. And it goes to almost present day, probably about 2015. This graph is a couple years old yet. But it's showing us the temperature recorded by 4 different government agencies. So we have the Japanese Meteorological Agency, NOAA, the National Climate Data Center, the Met Office Hadley Center and Climate Research Unit, and then, of course, NASA. Pretty big companies there. They're significant. And they're showing us the temperature change throughout a year. So in 1880, we're actually about 0.25 degrees below the average. Our trend from 1880 to about 1910 is actually down. We're actually seeing, at that point, we were actually seeing a decrease in temperature. And then just post World War I, from 1910 to about 1940, we start to increase in temperature. Does anyone have a guess why that is? So the main reason why we start to see that increase in temperature is at the end of the 1940s, we had what major conflict occur? World War II. All these U.S. men went off to war, and they needed tanks, they needed weapons, they needed resources to help them fight over there. You see a lot of industry rise up because of World War II. And then when they get back from war, all these American citizens come back. They're expecting good jobs, good wages. They get factory jobs. And they go to work in the factory for their next 40 years of their lives. And that industry actually ended up causing a slight decrease in temperature, where we actually went from average down just below annual temperature anomaly. And that was just because of some of the emissions that were being released. So some sulfur dioxides that actually blocked out, caused a lot of smoke in the sky, actually blocked out the sun and decreased temperature. So we actually see temperature decrease for a couple of years, about until 1975. And then in 1975, CO2 levels started to rise significantly. And that's where we've seen this positive trend where temperature has continuously increased and continues to increase even now. The hottest years ever recorded have occurred in the last 5 years. And the trend continues. Hopefully in 2019 it doesn't continue. It stops and we don't have a hot year. But based on the trends we've been seeing, that's what's probably going to happen. So with this increase in temperature, we start to see some of the obvious things that you've learned about before. We see melting glaciers. And when glaciers melt, glaciers are just giant blocks of ice sitting on our North Pole, South Pole, or on mountain ranges. When those guys melt, that water has to go somewhere. Eventually it makes its way to the ocean. And when the ocean gets more and more of that fresh water, coastlines, the ocean rises, goes up, and coastlines drop.
Hello.
So,
do you know anything about...
So what we're seeing as far as melting glaciers go, gotta go back, is as this water empties off of these glaciers, as these glaciers heat up, that water gets released and ocean levels are starting to rise. And when ocean levels rise, we lose land, we lose habitat, and we also lose a reflective surface. So during the hot summer, people tend to wear white shirts, white dresses, white hats. Reasoning why: white is a reflective surface, right? Light reflects energy. White reflects energy, reflects light back. So if we have a white surface like a glacier covering our north and south poles, we reflect more light. But as we decrease the amount of glaciers we have, we decrease the amount of the white surfaces we have on the planet. Now we're replacing it with a dark ocean. And darker colors absorb more light. So we're going to increase our temperature as we lose more glaciers, more of that reflective surface. If we look at this picture of South or Antarctica, we can see the loss of ice over their summer. So as in January, we start with a lot of ice. As it starts to warm up in January for Antarctica, we're losing that ice. And then what happens as we lose that ice, we expect global temperatures to increase. Here's an easy graph just kind of showing this. In 1850, we were losing glaciers at 200 millimeters. I'm not for sure what that unit is. But if we look now, in the year probably 2008 or so, this graph's a little bit dated, we're losing glaciers at negative 1,600, which is a significantly greater increase than it was in 1850. So we're losing glaciers much faster than we were previously. In fact, up until 1970, we were holding pretty steady, and then our amount of glaciers that we've lost has pretty much crashed since 1970. Which, if we think back to our annual temperature increase graph we had, 1970 was the point in the graph where we're starting to cool, and then temperature was increasing since then. So we can kind of see how these two graphs relate to each other. Like I was saying, that meltwater from the glaciers has to go somewhere. It's not just going to disappear. It doesn't just evaporate and go into the sky. It has to go somewhere. It runs into the ocean, and that ocean level rises. And when that ocean level rises, we potentially will see 3 feet increase of ocean temperature by the year 2100. So 80 years from now, if we don't change the way we think about energy, we don't change how much CO2 we put into the air, we're going to see an increase of ocean level by 3 feet. This change is going to change our ocean currents, which change how the earth cools, how our weather patterns occur. And it's also going to lead to the destruction of most of the U.S.'s significant cities, our largest cities along the coast. If we look at this map here in the bottom right, Boston, underwater. New York, underwater. Washington, D.C., gone. Charleston, off the map. Tampa, Miami are miles into the ocean. No Florida. New Orleans, gone. There's now going to be a bay that extends from what would have been Alabama and Mississippi all the way almost to the southern tip of Illinois. So Illinois, if the trend continues, will have oceanfront property. Probably the only positive to look for people that live in Illinois, that their property value will increase. Here we have a video that kind of shows projections of what the coastlines will look like if we don't change the way we think about energy. So we're zooming in on this globe here, and we can see how these ocean levels, if they rise 3 feet, what we're going to expect to see. Australia is now going to have a giant lake in what used to be a desert. Europe, We're going to lose Copenhagen, Stockholm, St. Petersburg. London will be underwater. Brussels, Venice is going to be completely gone. Barcelona, New Lisbon, gone. Africa is going to have a new coastline. There's going to be an island that forms north of Egypt. Most of India is going to be underwater now. Calcutta, one of the largest cities on the planet, is completely submerged. China is going to be devastated. Hong Kong underwater, Shanghai, Beijing, three of the largest cities. Tokyo, another large city, gone. Now we're getting over to South America. Amazon rainforest. The Amazon River is going to swell up, become like an inland sea, and the Amazon rainforest is going to be flooded out. If we continue to move up towards North America, Mexico doesn't look like it suffers too much. California, a little bit more inland water. Portland's gone. Seattle's underwater. Florida is wiped out. Miami's gone. New Orleans gone. Charleston's gone. Houston's underwater. Washington, D.C., New York are suffering. It's not going to be a pleasant experience. And you get the destruction of these cities. We got to think about, how does this affect you? How does this affect each and every one of you? So take a minute. Think about what the repercussions are of just raising our sea levels by 3 feet over the next 80 years. Think about how that will affect you. So once you've thought about that, you've had those conversations, do a quick research for me. Quick search, one way that climate change will negatively affect all people. So I want you to put yourself in somebody else's shoes for a minute. Here in Wisconsin, we won't have to necessarily worry about rising sea levels. We don't have glaciers in our backyard that we really need to worry about. So think about how this will negatively affect you. Take a minute, go on Google, pull out your phone, see what you can find. Pick something that you might not have thought about before and share it with somebody next to you. Just so we can get some ideas on the wide variety of changes we're expecting we're going to see. Some of you might have searched and found out about the economy. The economy is going to struggle. Does anyone have any reason why the economy is going to struggle? The economy is going to struggle because we're increasing the ocean levels by 3 feet. And we just saw a video that showed us that if we increase by 3 feet or more, we're going to lose a lot of the largest cities on the planet because they're found along the coast. And if we do that, those cities now need to be moved, or all those people that lived in those cities have to move. We got to rebuild those cities. We have to replace those roads. A lot of our energy is produced on those coastal cities. Exports, imports, everything is going to change. We're going to see a different world if this situation happens. I have estimated costs to the U.S., $265 billion, taxpayer dollars, going into reconstructing some of the things I've got listed above. $265 billion. That's a low estimate. If we're talking about losing New York, if we're talking about losing Washington, D.C., Miami, Tampa Bay, L.A., largest cities in the United States, we're looking at a lot more than $265 billion in taxpayer money that we're going to have to pay to fix those solutions. I have graphic here that kind of shows what the economic damages would be in the year 2090 if our path continues the way we've been going. You're going to have to remove cities and other things. As far as immigration, we just wiped out Miami. We wiped out Tampa Bay, LA, New York. These cities I just listed off are gone. They're underwater. People can't live there anymore. Where do they have to go? They're not going to stay there in their flooded homes. They're going to go someplace they feel safe, someplace away from the coast where they don't have to deal with these issues anymore. So you're going to see a lot of people, 144 million people at least, displaced by the year 2050 because of rising ocean levels. So the people in Miami, Boston, New York, where do you think they're going to move? They're not going to move to Florida. They're not moving to Texas. They're going to move where the ocean won't affect them anymore. And you're going to see a lot of people migrating to the Midwest, the Western United States. So you see population rise in these areas. And 144 million people moving, we got to have a place for them to live. So you're going to see a lot of building going on. If we take immediate steps right now, tomorrow, a year from now, if we take immediate steps, minimum 40 million people are going to be displaced. Still significant. 60 million Floridians will lose their homes because Florida is going to be underwater if we don't do something. We will lose Florida. This isn't an estimate. This is fact. This is what's going to happen if we melt our glaciers and increase ocean levels by 3 feet. We're already seeing it now in weather patterns. We see hurricanes like Hurricane Sandy heads north to New York, floods the city. Yeah, so then we had Hurricane Irma down south in Houston, flooded the entire city. Thousands of people lost their homes. This is just the start of it. It's not going to get better. We're going to see a lot more of these weather patterns become more extreme as we keep adding more and more water to our oceans and changing the way our ocean currents work. Agriculture. Plants are dependent upon CO2. And what we actually see is plants actually have been producing fairly okay with our rising CO2 levels. Plants need that CO2. It was actually helping them for a while. As we keep increasing CO2, we're actually going to drown the plants in CO2. They're not going to produce as well. They're not going to do as well. And that's just the crops alone. Manageable land is going to go down. We have more areas flooded. We have more areas experiencing extreme drought than before. We're losing our cropland because of this extreme weather. Crops are getting flooded out. Areas are too dry to actually have crops. It's an issue. We're going to see increases in extreme heat patterns in our summers. Loss of livestock due to heat waves will increase. We've already seen it happen. If you click on the link here, agriculture, that's a website that specifically talks about how increasing in heat climate leads to heat waves that result in loss of livestock, which cost farmers thousands of dollars. If we look at this map here, change in numbers of days above 95 degrees to change in average summer temperature. Red means we're increasing in temperature. Yellow, pale yellow to light yellow means that we're maybe increasing a couple days, not many. Wisconsin, where we're at, we're increasing about we've got 10 extra days a year that are above 95 degrees Fahrenheit. So a third of a month, 10 more days where we're above 95. If we look at long term over the entire summer, that's an increase in Wisconsin about 4.5 degrees, where our average temperature over our summer has increased by 4.5 degrees. Here's a graphic showing the impacts of global warming and climate disruption on agriculture. So if we look agriculture in the middle, productivity is in the center of all this. Desertification. So we're turning manageable cropland into a desert because it's experiencing such rapid drought. Fresh water decline. Our aquifers, where that water is stored, because we're experiencing more drought, we have to use more of the aquifer water, and we're losing that to evaporation. Altered precipitation. Our weather patterns are more erratic. We don't get a lot of small amounts of rain anymore. If it rains a lot, and it takes a long time for that rain to get here. Biodiversity loss. Our environment is going to suffer, which means our agricultural productivity is going to suffer. So there's a whole bunch of connected things here that we need to think about if we're going to help keep our agriculture productivity up. If we don't, we're going to suffer. And I get this question a lot from a lot of different people, adults, children, kids your age. What can I do? I'm only one person. What can I do? How can I change global climate? What effect can I have? And I tell these people, you have more power. Kid your age has more power than any other generation before you. You have the power of the internet at your fingertips. If anyone's going to change the world, it's you. It's every one of you. You just got to take the plunge. So what can I do? It all starts by making a decision. You need to make a choice in your life that you want to make a difference. You don't want to keep following have the same impact as the generation before you. You want to make the change. Make the generation after you have a better planet, have a better place to live, because we only have one. We haven't even been to Mars yet. So we only have one planet. Second thing, use fewer resources. Don't take a 10-minute shower in the morning. Take a 5-minute shower. That's plenty. If you're brushing your teeth, turn the faucet off. You don't need the faucet to run while you're brushing your teeth. Get the toothbrush wet, brush your teeth, make sure that water's off in between. You don't need to use that water. Less electricity. If you're not in a room, turn the light off. Turn the heat down a degree or two in your house. During the summer, turn the air conditioning down just a degree or two. Save on those electricity. Something you can also think about is there's plenty of electrical companies now that do offer wind electricity, solar electricity. It is an available resource for you. You just have to decide to do it. You need to tell those companies, hey, I want to use renewable resources. Sign me up for this. Things to think about. It all comes down to starting the discussion. It takes one person to make this an issue. Talk about it with your friends. You have that conversation with your friends. Maybe they change their thinking. That friend goes and talks to 10 more. And it keeps going and going, and we start to see these trends change. I have a whole bunch of resources linked on this slide alone that help you get ideas. You can look at them at any time. This slideshow is available to you. If you need some guidance to figure out what you want to do, if you know you want to make that plunge and help the planet, use these links. Come talk to Mr. Anderson. Come talk to Mr. Wells. Talk to me. I will help you come figure out what you can do to help. Because this world is yours too, and you have a say. This is a video narrated by Morgan Freeman that talks about our future. Take a look at this, have Mr. Anderson play it for you here, just to get you an idea on what you can do, what your future holds for you. If we can help prevent this climate change that has been causing so many issues to our planet, and it's only starting. It's going to get worse. So take a moment, watch this video, and think about these things a little bit. It just starts by having the conversation and making the decision. Once you've watched this video, there's another video called Dear Future Generations, called Sorry. It's a rap that a guy produced about the things that generations have failed. So if you want to watch this, this is up to you. You don't have to. It's there if you just want a little extra information. It's kind of cool. It's really well done. But that's all I have for you today. So I hope you guys have a good rest of your day. Make sure that you complete your notes, because those are always important. And Mr. Anderson will take over from here.